I'm your host, and welcome to our exploration into the source material today. Imagine you're standing on the sidewalk, looking up at, a towering 100-story skyscraper under construction.
I'm your co-host and resident expert. And yeah, you'd look at that building and just assume someone in a planning office somewhere completely nailed the foundational physics.
Right, exactly. The architects calculated the structural load, they tested the bedrock, and they know the exact reason that building is going to survive a windstorm.
Because the physical laws there are just, well, they're non-negotiable. I mean, the engineers know the exact load-bearing capacity of every single steel beam before a crane even lifts it off the ground.
But then you look at artificial intelligence today. We're rapidly building these towering, multi-trillion parameter megastructures.
Huge ones.
Yeah, massive ones. And if you actually corner the engineers and ask them how the cognitive bedrock of their system works, like how the intelligence actually functions under the hood, they kind of just shrug.
Which is wild,
Yeah,
honestly.
it really is. And that is exactly why we are so glad you, the listener, are joining us for this exploration today. We're looking at a really provocative 2026 working paper by Angel Frias-Martins, and it's titled The Missing Theory of Intelligence, a Research Manifesto for the AI Era.
It's such a critical read right now because it tackles this glaring scientific asymmetry. Our AI engineering is advancing at warp speed, but our actual scientific understanding of what intelligence is remains fundamentally missing. We are essentially building without a theoretical blueprint.
Okay, let's unpack this, because looking past the daily hype of benchmark scores and tech announcements will completely change how you view the AI tools you use every single day. So let's start with those test scores.
Right, the benchmarks.
Yeah, because according to the 2026 AI Index, frontier models are passing bar exams, writing complex code, solving advanced math.
Doing incredibly difficult things.
But at the same time, they fail at basic perceptual or logic tasks that a literal child could do. The manifesto calls this jagged competence. I love that term, but I do have to push back a little here.
Go ahead.
Wait, if a system can pass a bar exam or, code a whole app from scratch, doesn't that inherently mean it's highly intelligent? I mean, it's like a friend who can instantly multiply 10-digit numbers in their head, even if they sometimes, forget how to tie their shoelaces.
What's fascinating here is how the paper untangles that exact contradiction. It draws a hard boundary between two concepts we usually mix up, which are skill and intelligence.
Okay, how are they defining those exactly?
Well, a high score on a static test just proves a model has acquired a skill. It likely just memorized the pattern through brute force exposure to, billions of pages of data.
So just regurgitation, basically.
Exactly. Intelligence, under this framework, is actually the efficiency of acquiring a skill and then transferring it to a completely new, unforeseen environment.
Ah, I see. So it's the difference between memorizing the exact answers to a test versus actually understanding the concepts well enough to solve a puzzle you've literally never seen before.
Precisely. And speaking of those tests, the benchmarks themselves are, frankly, falling apart.
Yeah, the paper notes that manual reannotations of the MMLU, which is that massive famous multiple choice test everyone uses to prove how smart their AI is, well, it actually revealed non-trivial error rates in the grading itself.
Yeah, the tests themselves are flawed.
Plus, you look at the chatbot arena, where models are pitted against each other, and it shows these systems are essentially just adapting to the style of the test. They're just gaming the evaluation.
Yet once a model has effectively swallowed all the test prep material from the internet, the benchmark totally loses its validity. This collapse in testing is exactly why the tech industry has leaned so heavily on scaling laws to drive progress instead.
Right. The old engineering rule of thumb. More data plus more computing power equals a better model. You see names like Kaplan and Hoffman attach to these scaling laws, allowing engineers to predict something called an average loss.
Which is essentially just the model's error rate when it's trying to predict the next word in a sentence. Give it more computers, the error rate drops.
Here's where it gets really interesting, though. Relying strictly on scaling laws is like knowing that pressing the gas pedal harder makes the car go faster, but having absolutely zero idea how an internal combustion engine actually works.
That is a great analogy. It describes what happens, but it doesn't explain the mechanics at all.
Right, it's totally descriptive.
This raises an important question regarding those internal mechanisms. Scaling laws cannot explain why an AI forms a specific abstraction. They don't predict what a model will successfully learn to transfer a concept, or, crucially, where it will abruptly fail. We have equations for scale, but no equations for understanding.
But wait, what about emergent abilities? For years, the narrative has been that when you make a model big enough, it just magically wakes up with new skills,
Like
right?
suddenly translating a language it was, never explicitly taught.
Yeah. Doesn't that prove the scale is creating something genuinely new?
Well, the research by Schaefer cited in the manifesto suggests those emergent abilities might just be a mirage caused by our own flawed rulers.
Mirage. How so?
When we measure models using discrete pass-fail scores, like getting a multiple-choice question completely right or completely wrong, it looks like a sudden massive leap in logic.
Oh, I get it.
Yeah, but when you switch to a smooth, continuous, metric-like, giving partial credit for getting closer to the right answer over time, those magical leaps just vanish. You just see a steady, predictable improvement in curve sitting.
Okay, if our rulers are broken, why don't we just look inside the AI and see how it's actually thinking?
People are definitely trying to do that.
The manifesto brings up the 2025 Anthropic circuit tracing study. They use mechanistic interpretability, which is basically trying to read the model's mind by looking at how individual artificial neurons fire.
But it turns out we only get what the paper calls partial causal access.
Right, we can see a few neurons lighting up, but we often don't really know why one triggered the other. We're basically looking at a tiny fraction of the computation through a keyhole. It takes immense human effort just to trace a single concept.
We just can't pop the hood and see a clean, understandable engine. And because neither test scores, nor scaling laws, nor looking at individual neurons provides a cohesive explanation, the manifesto outlines what a true theory of intelligence actually requires.
And the first requirement is acknowledging physical constraints, which means intelligence does not exist in a vacuum.
Exactly. It is physically instantiated, meaning a valid theory must include resource bounds.
Now, I have to challenge this premise because this part of the paper initially felt totally out of left field to me.
How so?
It argues that to measure true intelligence, we literally have to look at the resource cost, like the electricity bill.
Yes, the physical footprint.
But why should physical cost matter for a definition of intelligence? If a human genius eats 3 times as many calories as me, they're still a genius. Why are we penalizing the AI for its power bill?
Because a system that requires infinite unbounded computation to solve a problem is just not a useful operational model of intelligence.
Okay, fair point.
The April 2026 International Energy Agency report highlighted massive grid and equipment constraints caused by AI data centers. We are hitting a literal physical ceiling. If your theory of cognition requires boiling an ocean to learn basic math, it's a flawed theory.
So does that mean human embodiment? Like the fact that our brains run on roughly 20 watts of power is the ultimate gold standard we're trying to measure against?
Not quite.
Are we just trying to build digital humans?
If we connect this to the bigger picture, the manifesto's stance is actually a firm no on that. Human cognition is an impressive data point, sure, but it's not the universal reference class.
Okay.
A true theory of intelligence must be cross-substrate.
Meaning it doesn't matter if the intelligence is running on biological brain meat, silicon chips, or quantum circuits. It has to apply universally.
Yes, it needs to apply to neural networks, symbolic systems, animal cognition, and humans equally.
Wow, that is a broad scope.
It really is.
Yeah.
And because of that broad scope, this missing theory likely won't be one single elegant physics equation on a chalkboard. It will function more like a cluster concept.
Like biology, right? We don't have one single math equation that defines all of life. We have multiple interlocking theories for cellular development, ecology, and evolution that all kind of work together.
Exactly. That's the perfect way to look at it.
All right, so we need a cross-substrate theory that accounts for physical limits. But let me ask a really practical question on behalf of the listener.
Go for it.
Engineers are already building amazing things without this theory, so why should we care if the theory catches up? Like, is this just academic nitpicking? How do we actually test for this in a lab? If we can't use standard benchmarks, how do we prove a model is actually intelligent and not just a giant search engine?
The manifesto proposes a shift to a testing method called controlled novelty. Instead of testing what a model already memorized, you measure how efficiently it learns when faced with entirely new situations.
So separating the pure memorization from actual extrapolation.
Yes, and Proposition 7, or P7 in the paper, suggests something called resource normalized acquisition.
Okay, practically speaking, instead of giving one model the entire internet and another model a few textbooks, you put them on a level playing field.
Precisely.
Imagine locking 2 different AI models in separate digital rooms. You give them both the exact same 1,000 pages of completely made-up language and a strict, limited budget of computing power to read it.
Right.
The smarter model isn't the one backed by a $3 billion data center. The smarter model is the one that can figure out the grammar rules of that fake language faster, using only the limited resources in the room.
That is exactly the mechanism. It forces the industry to stop rewarding systems just for brute forcing massive amounts of data and starts rewarding them for efficient adaptation.
And building this theoretical framework isn't just academic nitpicking then.
Not at all. As these systems become more consequential and they're integrated into power grids and critical infrastructure, trial and error engineering becomes incredibly dangerous.
Yeah, the stakes are way too high.
Exactly. We need a scientific theory to predict systematic errors and establish failure boundaries before these models encounter novel situations in the real world.
We need to know the bridge is going to hold the weight before we let the cars drive over it.
That's the whole point of the manifesto.
So what does this all mean for you listening to this right now? The next time you open up an AI tool to draft a report or analyze a spreadsheet, look closely for that jagged competence.
You'll start noticing it everywhere.
You really will. Remember that you are interacting with an incredibly capable, hyper-optimized skill engine. It has acquired vast capabilities through brute force scale, but it does not necessarily understand the world the way you do.
And this leaves us with a fascinating, slightly provocative thought to take away from this manifesto.
Let's hear it.
If true intelligence is measured by the efficiency of acquiring new skills under strict resource limits, rather than just the final brute force test score,
Right.
could a highly efficient, tiny AI model running locally on your smartphone theoretically be considered more intelligent than a massive, energy-devouring data center model that just memorized the entire internet?
Oh, wow. That completely flips the bigger is always better narrative on its head.
Yeah.
We don't just need to build taller skyscrapers. We desperately need to understand the bedrock we're building them on.
We really do.
Thank you for joining us on this exploration into the source material. Keep questioning the information overload around you, and we'll catch you next time.